All right, today we have a more medium task. Let me share my screen. All right, so 852 peak index in a mountain array. You're given an integer mountain array of R elements and where values increase to a peak element and then to decrease. Return the index of the peak element. The task is solve time complete complexity. Log n. Okay, so it should be. So we need to log n, which is binary search. Binary search and it's guaranteed to be mounted array. So basically peak, I think peak is defined by num or like array I is more than array I minus 1 and also more than array I plus 1, right? I'm not sure about edge cases, so it shouldn't be edge case. Right, so let's go binary search. And for binary search, what we're gonna do, we're gonna define midpoint first. I know Python has a like binary search embedded, but let's implement it. It's fun. So let's define L as len. So what we're gonna do, we're gonna binary search array, and I still have to figure out how to do which way we go, right? So first for binary search, we defined midpoint, but we cannot do it. So we have our left and right pointer, which is complete array, right? While left less than R. What we're gonna do, we find midpoint, which is left plus right deleted by 2, and then divided by 2, I'm sorry. And then what we're gonna find, we're gonna check if our midpoint is peak. So if array, we got this point peak determination code here, and let's call it I, so I don't have to rewrite the whole thing. And we just return I, which is our else if this condition is not. Which one we have to decide, which one we have to take. For example, in this case, so we have, probably in this case it's gonna work. In this case, gonna work too. In this case, we select one. Yeah. I mean, we have to make a decision which part of the array we're gonna take. So if, for example, this will be like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And total is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So middle part will be 6, and we select 6. Then we have to decide, is this in here or is this in here? Can we make this decision based on something? So we can analyze ages, right? And somehow we can say, no, we cannot. So is it recursive then? So for example, if we have a function like, we'll say, peak finder, and we accept left and right, and then we call recursively from left to midpoint and from midpoint to right. Which is either, yeah. I mean, analyzing ages will not give us which way to look, right? Because it could be like this, could be 12. Analyzing ages, it's like, no. But calling recursively, how do we know when to stop? So we can say peak equal -1. Here peak equal I. And we call peak finder with 0 L, and we return peak. I can do that. It's not efficient because I can stop. I don't have to, I don't have to call it again if peak found first time. But because this is recursion, yeah, R. I less than L and I more than 1, because 1, if it's 1, it's 0 more than 0. Maximum recursion depth. Okay. Like this. Maximum recursion depth. Okay, so yeah, let's print LF and see what's going on. So I'm missing something here. I think it should be like L with I -1 and then I plus 1 R, something like this. Yeah, LR. Recursion depth exceed str project. Recursion depth exceed. Print finder. So first I go all the way to zero R, left, right. Zero, 3, and then 0, 0. So yeah, I have to get this. If left equal R, I'll just return. So I'll break recursion, yeah. There is no point, it's just one element. Oh, still, okay. 0, 3, 0, 0. Then 2, 3, then 0, 0 again. Why? Is it something wrong here? So if I have 0, 3, I do 0, 3, 1. If I have this part, it will be like 7, 12. 7 plus 12, which is 18 divided by 2, which is 9. Kind of correct. 2, 3, 0, 0 again, 2, 3 again, y. Yeah. Oh, okay, because this is like reassignment here. I don't need this reassignment from old part of code. Is there anything here as well? Printing a lot of outputs. Yeah. 2, 1, 3, 3, 2, 1. Why is this gone? question is, do I really need while loop? While loop is, what is while loop is looping? If I have recursion. So first 0, 3, and 0, 0, then 2, 3. Okay, let's run through this example. So we check in this 0, 3, we found I equal, let's print I will be 1. So we will check if more than 0, less than length, correct, and array minus 1, minus 1 which is 0, yeah, I think it should be more, which is correct. We do pick I, and we return pick. We shouldn't do any recursion at all. Why we got recursion? We should return. Maximum recursion again. Okay, so I is 1. So array 0, which is test result. Yeah, array 0 is less than array y. And more this is a peak. Okay, so this is different. We got 0, 4, which is 2, 0, 1, 2. And we check if 2 is not. So then what we're gonna do, we're gonna split it in another if. So we are not calling it recursively if there is a if we got out of range, we are not doing anything particular, but we still have recursion. Okay, 0, 4, so we have 2. 0, 1, 2. Okay, we have 2. then we can say, is this a peak? No, then we choose between 0, 2, this guy, 0, 1. Let's not do this crazy. Zero, 2, 0, 1, 2. Right. And this is not going to happen because 0 and 2, 2, and this will be 1. So we have 1, 0, 2. And we should return peak. Why it's not, we're not returning? We have 1, which is correct. Correct, and we return. We create peak and we return. On another thing, if L equal R 0 to another to 4, we get 3 to 3, we get 2 to 2 to 3. Why is this recursion is happening? So if left plus right, we calculate I, then we see if I is in a range. Then we check if I, and then we call between from L to I and from I to R. It's technically this, but I'm not sure why. Here, 1, 2. And we got 2, and then we get 0, 1, and we got 0. And then we got 3, 4. Yeah, we cannot call this. Yeah, maximum recursion. Why we have this recursion all the time? I don't understand. So if we call it, if this is between typical 3 2 3 4 3 1 3 1 3 1 and 3 1 is repeating. And left or left. Why is that? It's like this? Probably. Okay, so we have here, we have 0, 4, which is 2, right? We got 2, it's okay. Then we call 0, 2, and we have 1, which is okay. And let's print it, print pig found. I bet we found a pig, but something else happened. Pig found, yes. But then we check the right part. We check the right part, which is 2, 4, which is 3, which is 2, 3, which is 2, which is 2, 2. So we got if we got 2, 2, then we return. If we got 2, 3, we found peak and we still okay. So how we get out of recursion? We can say and or peak not more than 0. Yeah, okay, let's do south peak. It could be this Python thing. Yep. Still could be something that will make it stuck. I like more than sure about this. Yep, maximum recursion. Use that case. So we don't need this one. Let's print what's going on. So we take 5, then we take 2, then we take 1. So 0, 1, 2, 3, 4, 5, right? Then we take 0, 1, 2. So basically, if I have 0, 2, there is no point for me to check if this is a peak, right? So I could say must be more than 0, 1 and -1. Because peak cannot be last one. Still maximum recursion. My question is, is it really necessary to put left and right pointers? Is it possible that if I check this part, yeah, I think it is. So I get 0, 10, 5, 0, 5, 2, 0, 2, 1. Then I'm checking 2, 5, okay. 2, 5, I get 3, I check in 2, 3, got 2, I check in 2, 2, check in 2, 3. And this is again, why it's always like falling into this 2, 3, 2, then 2, 2, then 2, 3 again. So I have to call it if, how? But still, if I call it here, we will check, right? But why 2, 2, colon 2, 3? This is an interesting question. So if I have 2, 2, I just return. Maybe it was previous. This is 2, 2, this is 2, 3. And now I'm calling 2, 3, which it goes here. And then it's valid, it goes here again. And now so if left or right is if, or I can say, or right minus left less than 2, can I do that? Nah, in this case, nothing happened. Or right minus left. It's practically the same, right? Oh man, why? Why? This is because of this. Nope. This is working, but this is not. And if I do this, another part will be working, but not this one, right? Yep. It's like we don't have to check I. Oh man. Left is plus right. I can do cache like gallery. No, I can't do this. This is crazy. Okay, let's see what I can get. Topics, binary search, obviously. It's binary search, but which part should I search for? Okay, I have two parts, right? It could be here. It could be here. Which one should I search? Seven two means something here. 107. It could be something in here too. Okay, I can say if yeah, I cannot do that. So in this case, I miss the search. Yeah, it's it's over 30 minutes now, so I will probably take a break and continue working on it in part two. Thank you. Thank you for watching.